Hello guys, very happy morning to everyone of you. And now we are just going to see the next thing on probability. So before going to probability, let us have 5 minutes of discussion about the probability. So probability definitely you don't know. So it's a random measurement or outcome is uncertain. So sample space and the event is needed because event we are just getting the answer, and event it is the probability of getting which of the number. Okay. So it means some of the definition is 0 less than equal to probability less than equal to 1. So probability of sample is sample subset equal to 1. So U is union which is plus, and intersection is this one intersection of and. Okay. So you can see all times number in the same size. Okay. So that's when P union of B equal to P of A plus of P of B. Okay. So it means if A is an odd number, this kind of thing comes. So Venn diagram and P A union B, N of A plus N of B equal to this one. So if each and everything is being separate means N of A, so this can be disjoint event. Okay. N of A plus N of B, it means N of intersection A intersection of B equal to N of 0. Okay. So you can see probability of impossible event is 0. Okay. So probability of impossible, okay, probability of occurring equal to 1 minus 1 over not occurring, so not occurring equal to 1 minus 1 over. This one I just explain. These are extra things I just explain. Okay. Okay. So two tests repeatedly this 36 numbers, and some this one, and some 2 3 4. Okay. Next one is combination. So you can see combination permutation. So in number of permutation equal to linear arrangement. So number of times you can arrange, it means mode of n. Okay, we can arrange. So if a circular permutation means n minus of 1. Okay, it means permutation is considered comes under the category of arrangement, but combination is just a selection. Okay. So you can see next one, R permutation of n objects equal to n of p r equal to mode of n by n minus of r. Okay. So next one, R of combination. So this one, okay, mode of n by r mode of n minus of 1. Okay. Next one is n of permutation equal to n of the combination into r factorial. Okay. So 10 people are in the line. It means what is the total outcome? It means arrangement. You can see this is the total number of outcome is plus 1. So total outcome is 10. Okay. Because given 10 people, 10 people, and a certain pair of products together. So mode of n factorial, and we can just arrange this kind of factor into 2 like that. Okay. Total is 10. Okay. So mode of 10. Okay. So you can see this of 5 and this one also 1. Okay. We can just arrange in a different format. Okay. So this one I just explained to you. Okay. So this one is the most important thing, because you can see the it means the top value and bottom value should have each other. Okay. This is the main formula. P of A mode of B equal to probability of A intersection B probability of B. Okay. Number multiple of P. Okay, a factor. This thing. Okay. Another good thing. So this also is explained. We have that, but wait 1 minute. So you can see when 2 events are said to be indifferent if happening and non happening, one doesn't affect the other. Okay. Probability of completely wrong equal to 0. So both of the things can occur. Okay, so you can see the probability of B by A is probability of B. Okay, just A intersection of B is the probability of A dot probability of B. So if A and B are independent event, so you can see A is happening and B is not happening. So A is not happening and B is happening. Okay, see these are the independent event. A is not happening, B is not happening. Okay, this one. So next one, addition theorem. So addition theorem, A and B are two events. So just so I think so again here. So now addition theorem, A and B are two events and A is included and B is not included. So either is only either or. You can see this probability of A union of B is probability of A plus probability of B minus probability of A intersection of B. Okay, this one time, this one time. Okay, this one setting, this is so minus of this intersection. Okay, so this is probability of A. So both happening. Okay, in the outer sector is both are not happening. Okay, so probability of not happening, it means you can see this is intersection of probability of not happening. Okay, so only within the center, so you can see A. Just show it now. Within the bracket here it's equivalent. So both two things is given. So this is A intersection B not happening. Okay, definitely B, it is A not happening, intersection of B happening. Okay, this one is A mode of B. Okay, so at the border thing is you can see this one. So A not happening, B not happening. Okay, so you can see which one, P of A union of B equal to P of A plus P of B minus of P A intersection of B. Okay, so you can see the probability of A not happening, intersection probability of A not happening, A not happening, and it's the intersection probability of B not happening equal to 1 minus the probability of A union of B. Okay, I think so you can see. So it means each and everything, it means like this, probability of A union B union. So this one you can see. So probability of A minus of the entire thing, probability of A of B intersection of C, probability of C intersection of C plus of probability of A intersection B intersection of C. Okay, okay. So now we can just directly go to the questions. So we can just write here. So you can see here, a bin in a hardware store contains 125 bolts. Bolts is 125, nuts is 200. 1/5 of bolt, 1/5 bolt defective. 3/4 of nuts is defective. One item is picked randomly. You can see probability that either item defective is not. Okay, so probability of A, it means defective, entire defective union of nut. Okay, so then probability of defective plus probability of nut minus of probability of defective intersection of nut. Okay, so it means you can see nut as okay, nut probability of defective, entire defective, you can see 125 into 1/5 2 so 25, that bolt is defective. So 200 into 3 divided by 4, 200. So 150 it is 150 nut is defective. Okay, so probability of defective is how much? 150 plus of 25, 175 plus probability of nut around, just to get nut around minus of nut is how much, 150. So 200, 175, 7, 375, 375, 155, 2, 2. So 225 is the answer. So just divided by the entire thing, it means 125 plus the remaining 200 means 325 will come, okay, means 220 minus of 325. Okay, that's it. I think so you can understand this one. So next one is scotch. Scotch, you can see spade, clove, diamond and heart. Okay, spades and clove are black and diamond are heart or red. Okay, so you can see spade, this one. So selection of one card, selection of two cards. So we can see when they asked about selection of only one card, means favorable outcome for the yes is only 4. There will be 4. Total outcome 52. It means probability of selection of heart means entire heart. So 13 cards, there will be 52. So ace or king. Okay. So probability of occurrence of A is this one and the king is this one. So this ace and king definitely can't occur within the one card. So king are going definitely here, this will be 1. Okay. So probability of A is equal to 4 C2. 2 cards selected. Okay. Before we had just seen only one card. 4 C2 it will be 52 C2. Okay. Probability both are king. So 4 C2 it will be 52 C2. Both are black cards. Okay. Then black card is 26 C2 it will be 22 C2. Probability both are hot. So hot is almost 30 C2. You can see both are king or as. Okay. Probability of king and probability of as. So 4 C2 plus this one. So it's always is positive. So this one probability both are king. So 4 C2 and this one. Okay. This simple. This one is this one you don't know. Okay. But one thing here you can see 1 C2 is not possible because we are just selecting 2 cards. So 2 cards means here the 2 cards should be. Okay. This thing you can easily calculate. Just 20 seconds. So now we can just go for the next thing. So now you can see in the question notes video, a box contains 4 red and plus 6 black balls, and the 3 balls are taken random, one after another without replacement. So the selected set contains 1 red ball and 2 black ball. C1 divided by 10 C3 plus 6 C2 2 balls is 10 C3. So we just find the answer, we will just get the answer. And check. And 2 black balls. Okay. So you can see in this question. Here also so you can see and means multiplication. Okay, and is multiplication. So that's only we have been given here. Okay. Next one you can see about this one. The letter of word probability are in the not possible way. The chances that B and 2 I's are occur together. So total how much? 1 2 3 4 5. 1 2 3 4 5. So total 11. Total 11 letters are there. So they are asking only 1B as well as 11 I's. It means 2 I's, 2 I, 2 I. it's A and B. A and B they are both same, so they can arrange the same way. B, B same. So but in living things it is different. So A, B arranges to be differently. Trigonometry arranges differently. It is 11 means, so it can be arranged into 11 ways. Okay. So you can see now we are just taking the total outcome. If suppose we have 10 objects and 10 letters are there, so 10 factor will be mode of 2, because A both are there, so 2 times we can just arrange. So BP 2 times just divided by 2. Okay. So you can see in this total number is 11. So 11 divided by B is 2 times and I is 2 times. So divided by 2 divided by 2. Okay. This is total outcome. So what is the favorable outcome? So favorable outcome, just make the 2 B's as 1 plus 2 I's as 1 plus of remaining 7 units. 7, 8, 9. So 9 factorial. So in this what is the thing is, this piece can be arranged to different ways. This 2 also can be arranged to different ways. Okay. So that's why we take this as 1 factorial into 1 factorial divided by 11 factorial mode of 2 into mode of 2. Okay. So I think so we are ready. So we are ready. We will get the required answer. Okay, the next thing you can just work on. Just 1 second. I think so you can see statistics from ungrouped data is this one. Grouped data is this one. Okay. So mean is just summation of xi divided by n. Okay. It means summation of data with respect to total number of data. Okay. So next one is median. Just middle term. Okay. So odd means odd, it means average. Even, so if it's even means it is 2 days, just take average. Next one is mode. Most repeating frequent value. Okay. Mode equal to 3 times of median minus of 2 times of mean. Okay. You can see this can be used as indifferent time distribution. Indifferent means you can see we found 2 values but we can't find the third one. So example, mean, median, mode. In this 2 values we found but the third one we can't find, then use this formula. Okay. So you can see mean, just take all the summation of this and divide by total number of things. Okay. So next one is median. Okay. So in this, what is median? So mid value. Okay. You can see C1. So just take average. And what is the mode here? So mode you can see. So mode is most repeating value is which one? 2 is the most repeating value. Okay. So answer is 2. So next one is variance. So variance is average of squared deviation from the mean. Okay. Average of squared deviation from the mean is variance. So variance equal to sigma square equal to summation of xi minus u round square divided by 1. Okay. xi minus nu the whole square divided by n. So this is the variance. You get the average of square deviation on the mean. Okay. So for mean, how much the variation is there? Okay, this is called as variance. Okay. So variance can be written as variance square equal to summation of xi the whole square minus of n divided by minus of nu square. Okay. Summation of xi the whole square divided by n minus of nu square. Okay. Next one is standard deviation. You can see it is a positive square root of the variance. Okay. Standard deviation sigma is a positive square root of variance. So standard deviation sigma. Okay. So you can see how we can just calculate the variance of this one. So okay, so you can see xi minus of nu. So nu is average. Okay, just calculate the average. You can see this one. So nu is this one. Okay, I think so. Getting the point. So xi is this one. Xi 2 minus of the average 3. Okay, this one 1 minus of 3 average. So each and every time you just take and put here and just make it square. It means integral square. Okay. Or else we can also do like this. Okay. Summation of x square minus of nu square. Okay. X square means 2 square, 1 square, 3 square like that. Put here each and every time square minus of 9 divided by 6. Okay. We get the standard deviation. It means variance. So root of variance is standard deviation. Okay. So you can see measure of central tendency, central value, mean, mode and medium. So you can see dispersion. Speed of the, it means spread of mode from the mean. Data variation can be seen from the number 2. It means variance and standard deviation. So mean, you can see mean is minimum is 1 and maximum is 6. So value will come in between 1 and 6. Okay, definitely. So central value is just take an average. Okay. So minimum maximum we will take remainder and divide by n terms. Okay. So next one is most we can value and medium is middle term. Dispersion. So we first write an average term and while calculating a answer from the equation, if it comes within the value, it is possible. If it goes above it, it is impossible. Okay. So next one is skewness. Okay, skewness equal to symmetric and unsymmetric. You will say systematic distribution equal to systematic distribution. Okay, mean, mode and this one. Okay. So next one is positive skew distribution. So positive skew distribution is this one. Okay. So positive the mean side will be little bit like this. Okay. Next negative skew distribution this side. Okay. Just a different variation. So random variable for outcome we write them in a number value. Experiment a coin is tossed twice. Okay. Sample space as such. So random variable is x, number of hits, so number of hits equal to 0 head will come. Okay. 1 and 2 will come. So this is a random variable. Okay. Random variable 0 head come, 1 head come, 2 head come. Okay. Now we just put the probability. So 0 head probability comes means 1 by 4. 1 head comes means is 2 by 4. Okay. 2 heads comes 1 by 4. The random variable is now converted into probability distribution form. Random variable converted into probability distribution. Okay. Converted into probability distributions. Okay. So random variable associate real number to the outcome of the random experiment. Okay, two types. One is discrete random variable, next one is continuous random variable. Okay, discrete variable because random variables are 0, 1, 2 does it exist between infinite values 0, 1. So discrete means you just assume an value, and the continuous means it's been continuous. Okay, so x will be the number of hours. It means the time will be so much higher also. So continuous random variable you can see 0, infinite. So this is comes under the continuous random variable. So f of x, this one. Okay, what is the probability? Okay, so third one is wrong. Okay, you can see because it goes to negative, probability is always not negative, it only is positive. So table form given, use discrete random variable. Graphical form given, use continuous random variable. That's it. Okay, in this other thing is the, so before that I will have a good tasty biscuit. see probability mass function, probability density function. So probability mass function. So whenever discrete probability distribution given, we just take probability mass function. So generally probability of x is generally greater than 1. Okay. Sum of probability mass function is always equal to 1. Okay. I think you're getting the point. So probability density function is a continuous random variable f of x greater than or equal to 0. So you can see here we are playing interval. So minus infinite of infinite f of x will be x equal to 1. Okay. Probability of a less than x is less than b equal to, you can see, is a to be f of x of dx. Okay. Probability of a less than x less than or equal to a to be f of x of dx. Okay. So now we will just see certain enough problems. So you can see die is loaded so that the probability getting force. So you have to directly proportional to x. Okay. So probability of x is, so we will apply in end of case or conversion. So this is the type of discrete random variable. So you can see x equal to 1 2. So we will just get certain enough answer. So they just ask about which one. Odd number. Okay. You can see we just take the number is 9k. So the probability of x is 1. So the k is 1 by 21. Okay. So put the k value and we will get the required answers. So next one, a continuous random variable has probability density function. So it means 0 to infinite. So put 0 to infinite means x greater than 1. Okay. So put x equal to 1 and we will just take, okay, 1 to infinite and we will get the answer. So find the value of lambda is the probability density function. Okay. So just put integration of 1 to 2. If this is a function of it, just put here and calculate the lambda value. Multiply inside. Okay. After coming into a proper simple balanced solution, you can just proceed as upon. Okay. So next one is expectation. Okay. It is nothing but mean of random variable. Okay. Expectation is nothing but mean of random variable. So expected value of random variable x is divided as, you can see, e of x is summation of x is probability of x. Okay. X is discrete random variable, b of x is probability mass function. So next one you can see, if continuous random variable means minus infinite x of f of x of dx. Okay. So you can see summation of x is probability of x. So x is discrete random variable, p of x is probability mass function. So minus infinite of infinity x of f of x of dx. Okay. X is continuous random variable. So expected value is x square. So you can see next one, expectation. It is nothing but it can mean of random variable. Okay. Expectation means it means just an expected value. So expected value of random variable x is divided by summation of x probability of x. Okay. If x is a discrete random variable, p of x is probability mass function. And this one you can see minus infinite to infinite x of f of x of dx. Okay. X is continuous random variable. F of x is probability distribution function. E of x summation of x probability of x. Okay. So here you can see x is discrete random variable, p of x is probability mass function. So minus infinite comma infinite. So x of f of x of dx. Okay. X is continuous random variable. So you can see f of x is probability distribution function. Okay. So expected value of x square. So summation of x square probability of x. Okay. Summation of x square probability of x. Okay. Next is minus infinite of infinite x square f of function of x of dx. Okay. expected value of constant is C. And you can see expected value of Ax plus B equals A will come at the front. Mean equal to nu. Expected value of x. Okay. Next one is variance. Variance equal to E of x comma nu. The whole square. Okay. E of x comma nu. E of x comma minus u of the whole square. Okay. So variance. Variance of constant equal to 0. Okay. So variance E of x square minus of nu square equals to this one. Okay. So they are asking the mean value and variance. So the machine produce okay. So 0, 1, 2, 1 by 6, 2 by 3, 1 by 6. Okay. So they are asking the mean value minus E of x. Okay. Minus summation of x and probability of x. Okay. So x into it means 0 into 1 by 6 plus of 1 into 2 by 3 plus of 2 into 1 by 6. Okay. Well, you just mean what is the mean value is 1. Okay. What is variance? So variance equal to E of x square minus of nu square. Okay. E of x square minus of nu square. Okay. E of x square minus of nu square. So you can see what is the E of x square. It is summation of x square probability of x. Okay. Minus of nu square. It is summation of x square probability of x minus of nu square. So x is 0 the whole square into probability of 1 by 6 plus 1 square into 2 by 3 into 2 square into 1 by 6. So it is actually 1 by 3 is answer. So minus of 1. Yes, this is most important. Nu square is also most important. That will be the next question. Next one, you can consider the following probability mass function. Okay. Probability mass function in this category we need to just go. Okay. Q is x equal to 0, 0.4 and 0.6. Okay. So this thing. Okay. They are asking the variance. So first we need to find the mean value. Okay. You can see mean equal to this one. X is f of x. So 0 into 0.6 will be okay. Nu square 0.6. So this one when you just multiply you will get right by the answer. Okay. I think you are getting the point. So each of the 9 words in the sentence is the quick down. Okay. For example 3. Okay. So suppose if you just place it in means x is 3, 4, 5. So you can see 3 comes 4 by 9 and 4 comes 2 by 9 and 5 comes 3 by 9. Okay. So next one is mean. So expected length means definitely is mean. Okay. This one is the variance calculator. So next one is continuous probability distribution. So one is uniform distribution. Uniform is instead normal distribution. So just about 1 sec. I'll just explain you why the probability mass function and why probability mass function. Tell me about probability mass function and probability continuous function. And why mean and variance are important. Tell me along with an example. Probability density function and also explain me why these functions are needed with an example and tell me the mean and variance of this. So you can see, so discrete, suppose for example if probability mass function gives probability of each exact value. For example tossing a fair coin, it means random variable, so probable values. Okay, so you can see probable values x equal to k equal to k equal to k. It means 1 by 6. Okay, so probability density function you can see for continuous random variable like height, weight and time and temperature. Here the probability of an exact point is 0 because value is infinite. So instead of we calculate a probability over an interval of time. So probability of we'll just apply the integration. Okay. So you can see why mean and center is important. Mean just tells the center and average of the distribution. Okay. So you can see for discrete you can see this one. So summation of x into probability of x. Okay. But continuous you can see integration of x function of x of dx. Okay. So variance you can see this one. So summation of x the whole square minus of nu the whole square. Okay. So you can see mean it means 3% the average performance. Okay. This one. Okay. So for example you can see suppose a soldier is firing 3 bullets at a target. So at the beginning because probability start from 0. Okay. 1 0 1 2 assuming the probability is good. Okay. Suppose 0. So according to binomial distribution, so you can see probability it means he fired 3 bullets. So at the target may be it means the target may hit or may not hit. So it depends because probability of it is 0.5. According to binomial distribution, you can see we are just taking the binomial distribution. So mean is 1.5. So variance is 0.75. So probability mass function density function tells how uncertainty is distribution. Okay. In real life, in defense, precision missile accuracy requires knowing probability distribution. Engineering material failure strength is probability distribution. Okay. I think so you're able to catch up the points. So you can see variance is this one and this one is okay because now until now you just seen the thing. And expected value means it's just an expectation how much the value will come like that. So next one is continuous probability distribution. So uniform distribution, a continuous random variable. X is uniform distribution. So x it means summation of u a comma b. So function of x is 1 by b minus of a. It is probability distribution function of x is 1 by b minus of a. So what is the mean value of continuous probability distribution? Mean is a plus b divided by 2. Okay. Variance is this one. Okay. B minus a divided by 12. Okay. So you can see a random variable is uniform distributed over unit all its variance. So AB. So 10 minus 2. I think so you can do this one. So next one, suppose you break a stick of uniform. So it is asking the expected value. So you can see. So uniform distribution. So you can see length of shorter. Okay, 0.1 by 2. So addition will give required answer. Okay. Next one is exponential distribution. So this is a case of continuous random variable x. Okay. X is e of f of a. X follows exponential data with parameters. So probability distribution function you can see probability distribution function or exponential is lambda e power minus lambda of x. Function of x is lambda e power minus of lambda of x. Okay. So x greater than or equal to 0. And now what is the mean? Mean is just an expected length. So minus infinity to infinity f of x of dx. Okay. So what is the mean? Mean equal to 1 by lambda. Okay. Variance is 1 by lambda square. So next one, normal distribution. Just 1 second. Maybe in the next class I will just complete the entire thing. So after that we will just see some kind of problems. So we will have a good clear understanding. So normal distribution is continuous random variable. X is normal mean of standard deviation. Okay. X is follows normal distribution. So this is a probability density function equal to 1 by sigma root of 2 pi e power minus this. So this one. So standard normal variation that equal to x minus y dot by sigma. Okay. Standard normal variation that is allows that equal to factorial of n. So nu 0. sigma, this one everything. Okay. I'll just tell you the next chapter. Okay guys, then that's it for today's video, and I'll see you in the next video.